Okay, welcome back to the video. This is the second part of the video, and in this video I will talk about some applications about coloring graphs. Well, actually there are many applications about graph coloring. Okay, so we're not just coloring a graph. Actually, we can apply the concept to some other different problems. Now, imagine that, for example, you have a group of objects and you need to assign some labelings on those objects. Okay, so those, as I said, actually those colors, okay, they are nothing but just labelings. Okay, so just think about just some names. Okay, not very necessarily mean the colors. Okay, you can just think of it as some labels. Okay, so this is something you need to do. So then now there are some restrictions. Okay, restriction on the labels. So the labels have to be in some sense distinguishable between objects. So that means after you put the labelings, okay, uh, you, you have to you can distinguish the objects using the labels. Okay, so that's the purpose of putting those labels on the objects. Okay, so if you have that kind of problem, then maybe you can use graph coloring concept to solve it. Okay, so really, is there any real life problem that really need the graph coloring method to solve it? Well, there is one. So imagine that you have to make some uh, exam schedules. Okay, so I mean exam scheduling. Okay, so exam scheduling problem. Okay, is a very painful problem for the teachers. Okay, maybe for the students as well. Okay, I don't know, but if you really need to make a schedule for the students for the exam, then what do you have to do? Okay, well, of course, um, you have to make the exam papers, right? I mean, but not just the exam papers. You also have to assign exams time slots. Okay. For example, you have a list of courses. Okay, you have a list of courses. Then you have to put some time schedule. I mean, time slots. Okay, to the courses. Okay. Then how can you do that? Well, of course, you can just randomly uh, put some time schedules to the courses, but you might have a problem like if there are students who take the two courses at the same time. Okay, then if that two courses they they both have exam in the same time schedule, then you have a problem because the students cannot do this exam at the same time. Okay, so that means you cannot assign the same exam time slots for two courses with some common students. Common students means some students both taking the courses. Okay, I mean taking both courses. Okay, if you have that situation, then your exam schedule is bad. Okay, now under that restriction, then how can you obtain the exam schedule? Okay, now I have explicit examples in my lecture notes. Okay, so you can go back to the lecture notes here. Okay, now imagine you have how many courses? So you have 9 courses, right? Yeah, 9 courses. Now this is the conflicts, okay, between the courses. So the meaning for the clause means that there are some students enrolled in the two courses at the same time. That means for these two courses, they cannot have the same time slot for the exam. Okay, otherwise the student cannot do the exam at the same time. Then how can we solve the problem? Of course, one easy way to solve it, just like the coloring mapping problem, coloring graph problem, is you just assign 9 different time slots for the courses. Then you're done, right? But imagine that your school is not that big, or if you don't have that many available days for the exam, then you have to save your time and save your cost in order to make the schedule. So that means you cannot just be too generous, okay, in the sense that, okay, just put 9 different time slots and you're done. But okay, this is not a very good way to solve the problem. Then how can you do that? Well, let me go back to the notes. Well, now you can transform the problem to a graph coloring problem. Okay, so trust me, this is the really true method to solve the problem. Okay, even though you ask some schools, okay, when they're preparing for the exam schedule, okay, of course they may have some computer program to help them to do the problem, but the algorithm behind the computer program, I'm quite sure that is based on that graph coloring problem. Okay, so now how can we do that? Well, of course, when you're doing the transformation, you have to identify the vertex and the edges to the original objects. So now we have the causes, right? So now it's very natural to identify those causes as vertex. Okay, and now how can you draw the edges? Well, in order to draw the edges, okay, you better know the relationship between the causes. Now, again, you don't want two courses with common students having the same time schedule, right? So that means when you're doing when you really want to do the coloring, okay, so because remember, if you have an edge between the two vertex, you won't color them in the same color, right? That means how can you draw the edge? Well, of course, if they have some common students and wrote it, then there should be an edge between the corresponding vertex. Okay. Then now to assign the exam time slot, okay, it's nothing but just put some color on the graph, okay, because as I said, colors are nothing but just some labelings, okay. So for now, the labelings is the time schedule, time slot. So for example, course 1, I put certain time slot to that. So that means I just put some name, okay, on that course. In other words, some color, okay. So now we clearly know what to do, okay. So first, we change everything to a graph. But how? Well, we identify the course to the vertex, okay, and then we draw the edges. And then now we label or we color that corresponding graph. Okay, once we get the corresponding colors, we solve the problem because the colors will give us the exam schedule. Okay, so that means if the two vertex are linked by some edges, then they cannot have the same color, or in other words, time slot. Okay, once you can do that, you solve the problem. Okay, now go back to the notes. Okay, and you can see that after you transform this schedule, the relationship between the causes, you get this graph. Okay, it's a pretty complicated graph, I can say, because you see there's this even a star-shaped edges, okay, appearing in the graph. So sometimes it's very complicated, okay, but still you can get the corresponding graph. Okay, once you get the graph, you just do the same thing as before. You find a color on this graph. Okay, now how can we really do the coloring? Well, okay, so to do the coloring, okay, there is actually a concrete way to color it. Okay, this is called the sequential coloring, and that will be the third part of this PowerPoint as well as the video. Okay, let me just pause it, and then you go to click the third part for the video, and you will see the details for the algorithm.